Hi, I'm Giridhar, working as staff engineer at Walmart Labs. This talk is about why and how we are using Kafka streams in our team for stream processing. We will cover how Kafka streams differ from already existing stream processing systems like Storm and Samza. Kafka streams and Apache Storm are fairly similar. Both systems provide many of the same high-level features: a partition stream model, a distributed execution environment, an API for stream processing, fault tolerance, Kafka integrations, etc. But Storm as a platform does not have support for state management. A bolt can maintain in-memory state, but it gets lost on process or node failures. Kafka Streams has built-in way of maintaining state in a fault-tolerant way by storing state in changelog Kafka topics. Kafka Streams has borrowed good ideas from Apache Samza, like having native support for maintaining local state and also pushing state modifications to changelog Kafka topics, which can be read to build up state in case of process or node failures. Kafka Streams has few new features on top of what Samza offers, like standby replica tasks, interactive query support, and exactly once processing. Kafka Streams keep reading from changelog Kafka topics. Standby tasks keep reading from changelog Kafka topics that are being written by primary tasks and try to maintain almost up-to-date state. This helps in fast switchover when primary task fails. Traditionally, stream processing platforms wrote state to remote distributed databases which can be queried by other applications. But this involves developing new applications just to expose state present in remote databases. With Kafka Streams, we need not write separate applications to expose state. Kafka Streams natively provides all of the required functionality for interactive querying the state of your application. These two features are the main reasons why we chose Kafka Streams over Apache Samza. We made few improvements on top of what Kafka Streams offers. One is support for maintaining state queryable when task is in restoration state. Let me explain this. It is possible that standby replica is lagging arbitrarily behind in terms of amount of changelog it is yet to read. And in case of primary task failure and standby is trying to become primary, your state store will be in non-queryable state while standby is trying to catch up with the changelog. This would mean downtime for microservices written to expose the state. To minimize this downtime, we made changes to Kafka Streams code so that store is queryable even when task is in restoration state. Another change we made is having support for storage policies, like archival policy and TTL policy. RocksDB is natively supported embeddable database in Kafka Streams. It performs well on top of SSDs, which is costly. It won't be economical to store state which is not being modified for a long time in SSDs. So we offer archival storage policy to the users, which enables them to move such state to cheaper storage. State in HDD is also written to changelog Kafka topics, and it is also queryable. Another change we made is one-hop queries. Currently, when client wants to read state corresponding to a given key, client might connect to any arbitrary node, and if that node doesn't own that key, it knows the owner of the key and it will fetch state from that owner and return back to the client. This introduces new hop. We made changes such that client can build a partition to node mapping locally and maintain this even during node failures or task movements from one node to another node. So that when client wants to get state corresponding to a key, it first figures out partition number and uses partition to node mapping to contact the node directly which owns the data. This reduces one hop. We made few other interesting improvements like ability to change the number of part topics with minimum downtime of the applications. We are exploring ways so as to not have any downtime. In the talk, we will cover all the implementation details of the above features mentioned. Looking forward to meet you all. Thank you for your attention.